Hello and welcome to another edition of Code Remix Weekly. We are your usual hosts, Sam, that's me, and Tim, that's him. How you doing, Tim?
Just fine, just fine. How are you?
I am also doing well. Glad to hear things are good for you. Recently, I have been enjoying going to concerts at our local zoo, which has a lovely kind of outdoor event space that after regular zoo hours they will set up and do a stage and host musical acts there. And that's fun 'cause it's a lovely field on a lovely summer or early autumn day. And the tickets go and support the animals. And
It's
before the
good.
show, before they're coming up making a bunch of noise, there may be a zoo employee or volunteer with a great horned owl or a big old snake or something neat like that. So recently I've seen Japanese Breakfast, which is a band, not a meal. Although it could also be a meal, but in this case it's a band. And Regina Spektor, who's
Oh,
a
nice.
well-known
Yeah.
piano player and singer there. So that's been a lot of fun. How about you, Tim? You been doing any fun like cultural events? You getting any culture recently? Movies, music, etc.
I went to see The North recently, which is a new movie playing right now, and it's about hiking, which I do with a good friend of mine, and it's
Okay.
just two guys hiking. I think 600 miles or kilometers. I don't know. At that point, it doesn't really matter anymore.
Yeah,
But in the
yeah.
north of
It's just version of the territory of a lot.
yeah. Hiking in the north of Scotland, which is very reminiscent of some hikes I've done in the past as well. And it's just all the good parts, all the bad parts. It's a very enjoyable movie to see. So
That's cool. I have very briefly visited the Scottish Highlands just on a day trip. We went on a family vacation to Edinburgh and took the train up to the Scottish Highlands, which I later learned, and this fascinated me as someone who had grown up in Louisville, Kentucky, other side of the Atlantic Ocean, that the Appalachian Mountains and the
yep.
Scottish Highlands once the same mountain range. Have we already had this conversation in a Code Remix? I
I don't
forget.
know, but it's that one, and I think the Moroccan Atlas as well. It's just
Yeah,
all of the. It's just one part of the range that was drifting apart, and you
yeah,
can hike parts of it. So if you do the full Appalachian Trail, you're missing
yeah,
some bits. You
yeah.
should go to Scotland and Morocco to finish it. So,
Yeah, to finish off the trail to really do the Pangean supercontinent walking tour. Yeah,
so
is that a
yeah,
goal for you? You like to hike and go camping? Are you ever going to do the whole Appalachian Trail, including Scotland and Morocco?
I, I'm more inclined to do the Moroccan and the Scottish trails
They're
than
a little more
maybe.
convenient for you.
Yeah, and, a bit less wildlife with fewer things to figure out in terms of like I don't know visas and things like that. So
Totally.
we'll see, we'll see.
Right on. So, what kind of updates do we have for this week, Tim?
We have quite a few. So let me share this quick screen. I'm trying to immediately share the right screen. That would be nice. No, not it. Yes. So one big update is that we're going to do another Code Remix summit next year. So if you want to join us in Miami, May 11th through 13th, that would be great. We'd love to have you, and from there you can learn more about OpenRewrite and Modern, and from other speakers from other companies as well, doing their own things in security and AI and automated remediation. So we had a ton of fun last year, or past, just before the summer, I would say. But we're really looking forward to having another one. So yeah, hope you'll join us there. And then if you want to speak at the conference as well, then that is an option too. So let me share the links just now. So we have one link to the conference itself for attendees, and then you can talk at the conference as well if you submit or call for papers and are selected. And then from there, we hope to host you in the Margarita Field again, I think. So, should be good.
It was a fun venue last time. It was a good conference.
Yep.
It had a lot of great speakers on a whole variety of topics, not only Open Rewrite and Modern, although plenty of that featured prominently, of course. And I imagine next year we will have an even greater variety of topics covering all the hot news happenings in our industry.
Absolutely. It's quickly becoming my favorite conference, which you should never say.
Yeah.
Oh well, you gotta have one favorite.
Yeah,
So
you've been to a lot of conferences, so if it's your favorite, that says something.
yeah, it's And then also new is like this afternoon we hosted yet another monthly session on OpenRewrite Amateur. So for the folks that want to learn from the comfort of their own home, you can now do the monthly trainings that we did. And we'll do an advanced OpenRewrite training 2 weeks out. So September 18th. You're welcome to join. It's on a European friendly time zone. So you won't see Sam. I think you were asleep while we did ours this afternoon.
It was about 4 a.m. my time when that one started, and I'm like, sorry, they're gonna go without without me,
which is fine.
And other great presenters.
Yeah. So we made you, and now, like I said, we'll have an advanced one in 2 weeks. So if you want to learn more about some of the topics, like data tables, traits, and things like that, they'll be handled in a lot more detail in that advanced session. So then, also new is that we have an article out on the new stack. So if you want to learn why AI alone fails at large-scale code modernization, then there is an article that you can go out and read. I've shared the link just now. And then from there, it's an interesting read by Olga in an interview style, and just showing while there is a lot of hype and promise with AI, it alone is not enough to allow you to make those reliable changes that we're after. And this just talks about what it is good for, and where you could maybe fill in with other technologies as well. So then beyond that, we have something interesting. We did a patch release today, and this patch release contains the first bit of our Java 25 support. So of course, as you know, in 2 weeks we'll have a new Java version. It'll be Java 25 coming out in 2025. And then from there is support for some new features within the language. There's some new migration recipes that we still have to run. But if you want to get started trying out those early access builds of both the OpenJDK as well as OpenRewrite, then now would be the moment to do so. So the first patch release, like I said, is out. We'll be following up with some more features that we're going to support specifically in the parser. So if you want to get involved there's still some things up for grabs. If you want to help, maybe bring flexible constructor buddies into the mix here. And then beyond that, we also, of course, have some migration recipes that we're eyeing. So some of these would be like nice to have, like there is already a clear alternative. There's others like switching you over to those unnamed variables. That would be very interesting to pull in the moment that we now have that parser support, and then be ready when the release comes in 2 weeks. So if you want to get involved, more than welcome. Otherwise, we'll diligently work towards it so you can at least reap the benefits of what we are working towards. So then beyond that, like we discussed last week, we're going to be at 2 conferences in parallel next week. So you can either catch us at the Gartner Apps conference, or you can catch us at the Swamp Up event. Both of them will be present with some delegation. I believe Sam, you were going to California, and then
Swamp Up conference, but don't worry, I won't take it personally if you choose to go to the Gartner conference in London instead of coming to see me at Swamp Up.
It is slightly closer
at all. A little bit.
Yeah. So yeah, looking forward to both of those. And then beyond that, we're gonna look at the main topic for this week, which is going to take a closer look at creating recipes with data tables. So for that, of course, we have a documentation page as a ready-made example of how you can already do this. But we figured it would be nice for you to give you a bit of a walkthrough of how you go about structuring such a recipe. And we're going to do that, of course, using the ever-present rewrite recipe starter that we have. And then through there, I'm going to live code, try to recall to memory what all we needed to include to do a data table recipe, and then explain some of the bits along the way. So if you want to get started reading the docs that we have on this topic, then I'll share the link in the chat just now. And do feel free to ask any questions that you might have in the Slack, over in the chat, so that we can tune this to helping you make the most out of the session that we have here. So with that, I'm going to switch what I'm sharing right now. And then I'll be sharing my IDE. And with that, you are seeing a bit of code already. So this is the, like I said, rewrite recipe start. So we have I'll share the link as well. If you want to clone this repository and maybe follow along locally, then that is an option too.
Are you a light mode IDE guide for your day-to-day development or just while presenting?
I am very much a light mode person. I do put on which I haven't right now, but I have a mode in the evening that makes it slightly more pleasing on the eyes.
Yeah,
so I enable this one.
The same thing. Sets the color balance to orange, reduces contrast a bit. Yeah.
Because I am very much an evening person, but I for this stream alone, I'm putting it in bright light mode for you all.
Very good, very good. Didn't mean to distract. Well, I meant to distract a little bit, but not too much.
All good, all good. And then with this placeholder, we're going to look at first an existing data table recipe that we have, and then from there try to replicate that to this recipe that we looking to implement still.
And for anyone who might not already know what we're talking about, a data table is structured data extracted or processed from code and documents stored in the LST, presented as typically a spreadsheet, but it could also be output as a JSON blob. So anytime you have a question that you want to ask, maybe not just of a single file, but of all the files across all of your repositories, and get back a whole list of answers that you could then post-process in your BI tools of choice, data tables might be the way to go. All right, light mode supporters coming out of the woodwork to back you up, Tim. So you're not alone.
That's good. That's good. So what's like you said, indeed, data tables are a really handy way for you to extract some form of data from your application. And we have a lot of examples in this space as well. So if you go to this particular page that we have in the OpenRewrite docs, you can get some inspiration of all the recipes that we have that produce some kind of data table. So this will be recipes looking at maybe vulnerabilities or finding SQL statements or finding particular dependencies or helping you gauge the specifics of a migration that is being done. All of these produce some kind of data table, and you can often jump into the source code of each of these recipes to figure out exactly how they do so. So know that these are out there, but we're going to, like I said, look at an existing example first. And then from there, look to replicate that in a new one. So in this case, you have one of those recipes. So we have a recipe here, which is called class hierarchy. And then you can see already it has some fields that you might not be familiar with if you not looked at data tables before. But what I found most helpful is to switch to the unit tests before we actually show you what we're going to expect to do here specifically. So in this case, we have our unit test for this recipe where we have, let's say, a class A that we're going to visit. And what we expect when we run this particular recipe is that we're going to produce a data table of rows. And in those rows, we're going to expect a single entry, which exactly matches this row that we pass in here. It all seems fairly straightforward, but we're going to expect here that we have a class A, which extends object and nothing else within this hierarchy. So this is a very basic way, but it shows you a bit of how you can actually write unit tests that help you exactly expect particular rows produced in this data table. Now, similarly, if we have a class A and a class B that extends A, we're going to start to expect two rows here. One for class A and the other for that class B, and then with a different superclass. So very straightforward. These tests, I think, will start to help illustrate exactly what we would expect from this recipe. And then there's a final one here where it implements an interface, and you'll see that that is also captured. So I think with that, you'll get a good sense of what your recipe does just from looking at these tests. And then from there, we're going to jump into the implementation. And here you can see some of those elements that we saw in the test come back as well. So we have our recipe. Like I said, it has a class hierarchy report. And this is our container for data table rows that we're going to produce. So you'll notice a couple of things here is that it is a field on your recipe, which typically we don't have a lot of fields on recipes. And that is because these recipes, they are typically serializable. So we want to be able to serialize them, deserialize them when we load them from a YAML descriptor, things like that. And typically any other fields would clash with that. So in this case, we've made this field transient to indicate that, yes, while this is a field on a recipe, we don't want it to be part of that deserialization. And I think if we forget this, we should get an error, right? So.
Well, I think you will. You would certainly get a compilation error as all of the constructor invocations and class hierarchy well, no, because you initialize it with the value. Yeah, you should get you'd probably get a serialization error from the tests.
Let's have a quick look indeed, if that is the case. And otherwise, it's one of those validations that we should add. Oh yeah, very much we get our recipe must be serializable, deserializable exception.
No. Which is something you can toggle off of the test validation. Every now and then I'll create a test utility, which, a recipe is used to test some other aspect of how the framework behaves that isn't supposed to be an actually shipping recipe unto itself. And so you could toggle off that validation, but don't if you're writing a regular recipe, since if that serialization deserialization doesn't work, like the CLI and the SAS, and that recipe might not be able to be listed within a YAML recipe, so you might not be able to compose it. So that is a fairly important validation, not to be trifled with.
Exactly. Like all of our validations, they can be turned off, but please don't. It's like if you're in a wood shop, there's a good reason that you have some security guards in place. You don't want to disable all of them, or you might lose some fingers. Yeah.
Good analogy.
So then let's just switch to the implementation of the recipe, and this is all there is to it. So you can see that it is very straightforward to create a data table from a recipe. Yet still we find from time to time that there's some confusion. Sometimes folks think that data tables are similar in the sense that scanning recipes look across all of your files and then from there produce a output or a report. So then they kind of conflate the concepts of data tables and scanning recipes, thinking that you should always have a scanning recipe when producing a data table. But that is very much not the case. So as you can see here, we just extend the plain recipe class because the way that data tables are set up is that they use a regular visitor. They have no need for a second pass, which the scanning recipe would do. And then from there, you can already push those rows into that field that we have without the need for a first accumulator phase and then only insert the data table rows. So while it's possible to combine the two, it's definitely not necessary. And we have an example now to show you exactly that. This is as plain as it can be. So then with that out of the way, you can see here that we are overriding the visit class declaration. And then from there, what we're going to do is that we're going to extract the type of the class declaration that we get passed in. And from that type, we only want to produce that data table of all the classes that it extends, all the classes that it implements. And you can see how we do so here by calling that get supertype and then inserting our first data table row. Now, what you can see here is that we have that class hierarchy report has a nested row type, which we can explore here, which is just a value class with some fields on it. Now these fields, they each have a column to document exactly what the column is of the values that will go into that row. And then it follows the same standards that we have for a display name and a description, where you have a very short one and a more detailed one describing exactly what you should expect to see here. You can see that we have support for enumerations here, like we have for the relationship, but mostly these are going to be very plain, very boring value classes, where you can say, I want to have these types of mostly primitives or enums reflected in the Excel file that you will produce. So very straightforward. Like I said, we have that report. It extends data table. It has that generic open nested row clause. And then from there, you have the whole structure of your data table outlined. So with that, jumping back to the recipe, you will see that we use the regular constructor for that row. We're passing all of the values that we need. So the first one for the type, then the enum, that this is a relationship extends, and then the super class that we are extending directly within this recipe. And then very similar for interfaces, we're going to do exactly the same. But here you can extend more, or you can implement more than one interface. So we have a for loop where we do that exact same mechanism of inserting rows on that report. Now, one thing to note here is that the first argument into that insert row is our execution context. And this is a bit of an implementation detail because this is where the row and the data is actually stored on that execution context. We don't recommend, or I'm not sure if we support it, to inspect the execution context directly, but it is helpful to know that it is stored in this way, passed along, and accessible.
If you look at the execution context under a debugger, you'll see that it more or less is just a map of object to object. So you can store arbitrary information in there, and it's carried throughout the whole recipe run. It is typically a mistake to use the execution context to transmit information between one recipe and another, or between one part of a recipe and another. That is meant to be, it's meant to be the execution context, not like the execution state. So if you find yourself wanting to reach for that map in the execution context to be like, aha, I'll store that my recipe has found a variable or a method of interest, and something else will respond to that fact later, maybe don't. Like, maybe use like cursor messaging or traits or a specialized sub-visitor, because with the life cycle of the execution context, the way it persists through all recipes in the recipe run, you could easily create interesting and hard to debug bugs for yourself. So yeah, it goes in the execution context, but if you find your recipe writing information to the execution context, not through one of our structured mechanisms like data tables, maybe stop and think about whether that's really a good idea, or maybe set yourself or someone else up for some challenging debugging later when they're trying to figure out why your recipe gives unexpected output in the wrong file.
Absolutely. And it'll, of course, only show up when you run against multiple files or larger projects, as opposed to the typical unit tests, which are very straightforward. So yeah, this is all there is to it to insert some rows, and these are then on the other end, if you use the Maven or Gradle plugins, picked up by the runner and written to your target folder or your build folder, where you can see the output of these recipes. If you're using the Modern CLI or the Modern platform, there'll be more helpful Excel exports available to you directly. And then from there, you can use these rows that are produced to build visualizations and show exactly some structure maybe to it. Maybe you don't want to have a very plain text representation of this hierarchy, but you might want to have some fancy graph showing the intertwined classes that you're using. And that is very much something you can do when you have a data table produced in this way. And then the visualizations, which I think we can probably handle separately in a follow-up session.
Yeah. So is that what our follow-up session next week is on? Are we kind of just continuing on to the next data table topic, Tim? Is that a preview? Is that a spoiler for next week?
I think next week we're going to do the opposite of what we're doing today. So today we're looking at data tables without using scanning recipes. Next week we're going to look at scanning recipes without producing data tables.
I see. Very good.
Just to separate those concepts very clearly, and then the week after we're going to conflate everything again by looking at data tables and scanning recipes in the context of traits. So that should be fun. So,
very good. Well, I mean, since we're not going to be touching on the subject of data tables much more deeply, I mean, specifically in those weeks, well, we're looking specifically at data tables this week. Do we want to show a visualization, even briefly?
Yeah, sure. If you do you have one in mind that you want to show or pull up right now?
Yeah, sure. I don't have a visualization for this recipe in particular, but I can show what it looks like to build a visualization based upon a data table, as well as what the source code for those looks like. So if I'll just I'll pull that
And
up one second.
as you search, I can also show you that there's another way for you to assert that a data table row is produced, which is slightly different. And that is for a data table as a CSV file. So we can use here the, what was it? The class hierarchy report files. And then we can pass in that we expect a CSV file. And we're going to expect a extends Java-lang object. And this all looks good. I'm not sure if the headers are included here. So let's see. It does expect the headers as well. And then we can mark this as a language CSV. Doesn't do anything, but we know it works. And now we have actually done a different way for you to assert that a data table is produced, not using that explicit rows and the objects that you have to recreate, but using the more familiar CSV format. And this is going to be the basis of the visualization that Sam is going to fill up. So
Yes.
figured helpful to show that there's different ways to do these assertions, and this one would align best with which we kind of expect here.
Yes, and for are you ready for me to jump in showing the visualization, or should I?
If you are, yeah.
Very good, very good. Okay, so let's see. So I'll go ahead and share my screen. We'll do not that one. There we go. Screen one. So here we have the find call graph recipe loaded up in the modern SAS, and of course you can produce data tables and visualizations from the CLI as well. I'm going to check don't include the standard library, because otherwise in real code you get a whole lot of such and such extends Java-lang object, which is not super interesting most of the time. So we'll just let this guy run on a couple repositories. Looks like we're getting a couple warnings relating to type references found in comments, which is not terribly uncommon, that you might reference a type in a comment that we're not able to resolve type attribution from, but that is also not super salient for this question, so I think those warnings are safely ignored. And we've got enough results here that I'm going to cancel the rest of the run so we can get right to the data table. And you didn't actually show them the data table produced by this yet, right?
Nope.
Don't think I saw that on screen while you were talking. So we'll just take a brief look at this data table while also rendering. This guy has two visualizations associated with it, both a data grid, which is kind of like a spreadsheet view, but a nice little searchable web component, and a UML diagram. So we'll just go ahead and run this visualization even as we download the data table, and hopefully these will just nicely complete in parallel and give us a lovely result any second now. Very good. The data table download has finished. The call graph data grid coming back with no rows seems not right. So maybe that's something to look into. But in the meantime, because we see that according to this data table, which the visualizations are going to be based on the contents of the data tables, we get out this data table. And the first few columns on this are kind of the provenance of the rest of the row, just showing which repository it ran on. That's standard across all data tables. And then we get into the specifics produced by this data table. And here we see that this is recording which class with which method name. Oh, this is a sorry. This is a call graph, not an inheritance hierarchy. So this is talking. This is a similar but not identical data table to the one uh, uh, Tim was showing you, where this is recording which methods call which other methods and which other classes. So you could use this to build a graph showing all of the calls in your code base. We had one customer who used this recipe and dumped the output of this data table into a vector database to make a searchable tool for navigating a legacy code base of several repositories that had been dumped in his lap. One of these, hey, the owners were all left the company or fired or quit or retired, decades ago, but this is still in production somewhere. It needs someone to be responsible for the bugs. So, eeny, meeny, miny, mo, it's you who's now responsible for this code base you've never seen before. And he was like, well, I've no idea what any of this is, but to start getting a handle on it, he used this plus some custom visualizations of his own via this vector database to get a sense for what the component relationships were across this code base. So yeah, so we see all of the raw information captured here in this spreadsheet of only 55,000 rows, and this was just running on the default repository set of a few only a few repositories. Let's see if this UML call graph will render any better than the data grid one did.
It's
Hopefully this doesn't also
55.
tell us 0 rows, but I fully expect this diagram to be an unworkable mess as it tries to make some kind of semblance of sense out of, again, 55,000 rows. So that's part of why these visualizations have some filtering options on them to limit it to a particular fully qualified name of interest. So maybe while that visualization chugs through and maybe it figures something out to show us that it's horribly convoluted, or maybe it crashes, I could limit this down to, let's just take, sure, any one type we found here and find the relationships to just this type. Yeah, I will be. Oh, it's rendering. Okay.
Yeah,
Plain
no.
UML gotta spit out an error. It's like this is too much. I can't handle this.
I'll,
Let's try filtering this down to just this one type, and that should produce something a little more manageable, maybe a little bit less likely to throw an error outright.
I'll admit at this point that I've used UML diagrams in the past that were deliberately a mess in how they rendered because they
Yeah,
were reflective of the architecture of the whole system, which was a mess. And then
yeah,
by visualizing that, suddenly it got priority to do something about it.
yeah. Yeah, so here we go. Now that we've filtered down this data set to focus on just one class and its relationship to the classes it calls into and that call into this, I don't know anything about this class, or I've never looked at it myself. We can already see, like, well, analyze file is that's recursive into itself and all the other methods in the class. Then we see all the other things that both it calls into and that call into it, and yeah, even just the UML diagram here for just this one class on a regular code base is kind of a lot. So I don't blame this visualization for failing to render a sane UML for 55,000 rows. Let's see if we can get this data grid to work if we pre-filter it down to this guy. And maybe while that runs, we can show you a little bit about what these guys look like. So I have opened up here the visualization repository where, let's see, so here is the Jupyter notebook, which represents the call graph diagram that I just showed you. And a Jupyter notebook, if you're not familiar, is essentially a set of a string of Python scripts that you can run to read, a CSV file, which when this Jupyter notebook is run by the SAS, this path will be swapped out for the path to the data table produced by the most recent recipe run. And then, you're filtering and you're post-processing, you're swapping and your style and presentation and what have you to ultimately produce the image that we saw there. And you can run the notebook directly and see that see it produce right there in your IDE. It's output for the sample data. So anyone who wants to fiddle with Python and Jupyter a little bit, and I do find the Visual Studio Code plugin for Jupyter works pretty good for these purposes, can put together one of these visualizations. Yes, and here we go. So the data grid was able to render when we limited things a little bit more rather than chucking all 55,000 undifferentiated rows at it. And we get a kind of similar view and a kind of custom web component showing us very similar things to what we see in the raw data table. So let's see. So, Tim, we have covered what it looks like to define a data table, how to do that in your recipe, how to test the contents of that data table in your unit test, and briefly touched upon visualizations that could be built upon it. And of course, you're not limited to using Jupyter notebooks for visualizations. You could load it up into Tableau or Power BI or just fiddle with it in Excel, whatever other kind of, make R scripts or whatever to operate on this information. The world is your oyster, as some people sometimes say. I don't know why they say that. I'm not a huge fan of oysters. It probably makes more sense if you really like eating oysters. You a fan of oysters, Tim? You like seafood?
Yeah, well, once in a while, like when I'm closer to the sea, which I'm not at the moment, and you don't quite trust it. But
yeah, fair enough. There's a lot of good seafood here in Seattle. I personally go for fish more than shellfish most of the time. But every now and then oysters nice.
Yeah.
Is there anything else we didn't cover about data tables that we should mention?
It's maybe good to point out here that with the visualization that you showed through the platform, that is showing you the aggregated data tables across a lot of repositories. In your case, at least 11, but that scales out to hundreds or even thousands. If you're using the Maven or Gradle plugins, of course, you're still limited to seeing data tables produced on a single project. So you won't be able to do those cross repository type of scans that we are able to do when you use the modern tooling that we have.
Right. Very true.
So then with that, we can try, a lot of learning is in repetition, to do the exact same thing as we saw in the existing recipe, but now build it up from scratch on the Track Java to-dos recipe that placeholder that we have. And then from there, I would think if we're able to reproduce it there, we should be good to, have folks follow along or write their own when they slow this down to a manageable pace. Does that sound like a plan?
Yeah.
Perfect. Then I'll share my screen again. And then we take into that Track Java to-dos placeholder that we have here. What I'm going to do is I'm going to try to recreate all the steps that we saw before. So as we know here, we have some instructions on what we actually want to do here. We want to have a recipe that tries to find any comments containing to do. And if they're in there, we want to add them to a data table. We can see that in the test as well. This test in particular is again using that way of asserting on objects instead of a CSV file, but I think the concept should be quite clear if we were to translate this into a CSV file. So we're going to find this one, and this one, and add each of those to our data table rows. So that's it, that's the promise. And then with that, let's try to see if I correctly remember all the elements that go into that. So as you'll recall, recipes are serializable, so we want to have a transient field. So that's the first bit that we need to get going. You can see that my IDE suggestions very much want me to finish this sentence in this one true way, which is already quite telling in what you should be doing. Let me mistype it briefly, because I've seen folks try to do something like this, where they know that data table is in generic method, and you can say I want to produce here a to-do comment report row and do it in this way. And if you come on, if you do it in this way, then you're being silly because it doesn't work. So
you do it this way, you're just being silly.
Yeah. So what you want to be doing here is, on the very least, on the right-hand side, use the to-do comments report. because otherwise I don't think the generics will work out quite well. And then just to be safe, let's do the same on the left-hand side as well. So you want to use concrete classes here. And this should then help produce the data tables that you're after without any surprises. You can see in this case, data table does extend the generic class itself. The to-do comments report extends the data table class with the row intact. And then we're going to produce these for any comments that we find. So that's part one out of the way. And then, of course, any next part of a recipe typically involves the get visitor method, which we're going to override get visitor. And then what we want to do here probably is override the new Java ISO visitor, because we're not going to make any changes to the concepts that we run against. And we're going to use Java ISO visitor using the execution context. And then here we have to make a choice, which exact elements we want to be visiting. And in this case, I know we want to look at comments, and comments are stored in space. And so we're going to override the visit space method here. And then we are already looking at the right elements here. Now we're going to do the typical pattern that we have, where we first call out to super, just so we don't forget to do so. Don't think it will matter much here, but it is helpful to always use that same pattern, such that when you see any diversions from that pattern, you know exactly that it is deliberate. And then from there, we're going to call get comments to get a list of comments that we have. And then we're going to iterate over that list of comments and wipe out all those helpful suggestions again. And then we're going to see what do we actually get passed in here. So we're going to maybe do something like tree visiting printer dot print tree, and then say comment. Does that work? No, it's not actually. No, it's also not a thing. So let's just set a breakpoint here and do the typical silly thing of printing out the comment text. Or the whole comment.
There's a couple kinds of comment. It might be a Java doc. It might be a regular text comment. So that is probably why you're not seeing the get text method that you are looking for just yet.
Absolutely. So this is why I wanted to set a breakpoint, so we can look at what is actually passed in here. So we have our comments, we have our singular comment. This one indeed is a text comment. You see that it has a text itself, a suffix, and markers. It is not a multi-line one. Others might be a multi-line one, which we can figure out if we want to handle that in our CSV file. Probably yes. And then we can see in this case, all three of them are text comments. So we can do a very simple check if there are an instance of text comment, just to make it easier to access that text here. And then from there, we are on our way to insert rows into our data table. So that's what we're going to do. We're going to add an if comment instance of text comment. And then we want to create that text comment. And then we have our text comment.getText. And that is one part of what we actually want to insert into our data table row. So let's see what else we need to create. So we're going to create a new to-do comments report row. And that one has three fields, or three columns that we want to look at. So there was the source path, the comment text, and the element type. So we're going to look at these. So we're going to call this one the comment text. Then we're going to have a string.sourcePath. And I'm going to, again, pause the auto-completion that we get, because it's a bit too easy to cheat in this way. Comment text. And the last one was the element that we want to have it produce, right? So the element type. And I think all of them are stringly typed. So let's do it this way. And now all that is left is to assign this row to a field. And then from there, we're going to insert this into our data table field that we have. We have our to-do comments report. We're going to insert a row. We're going to attach it to the execution context and then have that row right there. We need to consistently call this context. And this is the skeleton of what we want to be doing here. Now, in this case, we have our comment only. We don't yet have these two initialized, so let's see what we get if we just give them a dummy value and then execute our test. We will get a warning that we, of course, are using assert J, and the expectations don't quite match what we actually got. So in this case, we got some elements were not found and others were not expected. So we got a number of rows where indeed the source path is empty. The comment text is actually present, so we have successfully extracted that one, but we've not set that element type as we expected. And then for the other elements here, we see that the element type is actually expected to be defined like this one, like a class J method declaration. And the source path here is expected to be a.java to line up with that class that we have here. So let's try to work out the missing details here. First up, we'll notice that we need to trim that comment text that we have to not have the leading space, which is just part of it. So that's the first bit that we're going to fix. And then secondly, for the source path, we want to actually extract this. And the easiest way to do is to use the cursor navigation. So we're going to see in this case that we use the cursor to find the compilation unit. And once we have that,
and for anyone who might not remember off the top of their head, the cursor keeps track of where the current element being visited is in the source file by giving you reference to its parent elements. So if we're looking at a space, that space is attached to the prefix of some method invocation or what have you, and that method is inside a class declaration, that class is inside a compilation unit. So whenever you want to retrieve information from a parent or sibling element of the current element you're visiting, you can use the cursor to navigate up that hierarchy and then from there wherever else you might need to go.
Absolutely. So in this case, we're looking all the way up to the J compilation unit that is at the root for these types of files. But we can also look just at the current element. So if we use the getCursor.get value, we get the current value of the cursor, which in this case isn't the space itself, but it is the element that the space is attached to. And if we, on that one, call get class and then toString, then we have something resembling what we actually expect in our data table row. So if we now run our test, we remove the disabled and we actually execute it. Let's see if we have correctly implemented all the various parts. No, there is still one mismatch. So we expected to do have fun, but we also found some elements that were not expected. And that is because we're including two regular comments. So there's a regular comment here and another regular comment, and those should be filtered out. They don't contain any to-do items. So really, these ones we should be rejecting. So there's a final check here that we can do that if the text actually contains to do, only then do we insert the data table row. So if contains to do, continue. And now we should be in a state where our recipe actually does what we're actually after. So let's run this again. And now we have a recipe that is going to indeed find all the to-do items in comments on our Java elements and produce a data table containing exactly those that you can export and, I don't know, attach to a Jira ticket for your entire organization. All of the to-do items anywhere in the code have been produced with just 20 lines of code or so. So
not bad.
Yeah. So that is kind of what we show you. So if you want to grab a screenshot right now, just pause the video when you see this on YouTube. We're not going to share this, I won't say beautiful code anywhere, but it is going to be helpful for you to know that you need indeed that transient field with a concrete implementation Then a visitor, in this case looking at spaces, from there traversing any comments, rejecting the ones that don't have a to-do item. Use that cursor to get the source path in there. Use the cursor again, but then to get the element that it's attached to. And then the trimmed comment text to be able to handle this one. And we could, of course, expand this to look at Java comments as well and other types, multi-line comments, all kind of fancy things. We'll leave that for any future episodes. When we,
it's an exercise to the reader or watcher, as the case may be.
So I hope that's helpful to you.
Thanks, Jada. Yeah, I have been at Modern for 5 years now, which is just kind of crazy to think about.
Absolutely. Yeah, congrats. Have you done anything to celebrate?
Not yet. I wasn't even really thinking about it until I was just reminded. I mean, I think I last thought about it last month or so that it was coming up. But yeah, I should get my bright blue Modern T-shirt, just like the one you're wearing. Maybe get a little cake with Modern blue frosting and 5 candles on it. That could be fun. I'll let you know next week on our stream if I went through with it.
It is like we don't. Like, I think you're one of the first ones to reach the 5-year mark. It's like we don't quite have any traditions set yet where you get upgraded to maybe a purple T-shirt or anything like that.
I do like purple. Getting a purple T-shirt would be an upgrade. I don't think it's one of our brand colors, but hey, now's the time to introduce it.
I think if you've been here 5 years, you have some sway in what you want to.
The 5th year privilege is that you get to add one color of your choice to our brand style guide.
Yes. So yeah, with that, I think we're okay to wrap up for today. So I want to say thanks all for joining us again, and I hope this is helpful to you. And we very much look forward to what kind of data tables you will produce. And feel free to let us know in the open source Slack that we have. And
come join that open source community Slack and tell us about it. Put it in a YouTube comment after you like and subscribe, of course. And we look forward to hearing from you what kind of things you have used this technology to do or want to do with it.
Absolutely. And then we'll see you again next week, and we're going to talk not about data tables, but about scanning recipes. The other topic that allows you to look across files and build up a collection of knowledge, but not with the eye of producing a data table. So see you all then. Cheers.
See you then. Bye.